Hey class, our video today is the second radicals video. Today is going to be about dividing radicals, in particular rationalizing the denominator, which is something we've already done. So hopefully this will be a pretty quick video. We're on page 324 in the binder. We'll go on to 325 as well. So get to that page and then let's get started. What I want to do here is at the top of the page give you a little reminder about how we divide radicals. So in the margin at the top, let's just rewrite this little formula here, where if you have the square root, and make it a big tall square root of a over b, that is equal to the square root of a on top divided by the square root of b on the bottom, right? And one thing that's important to know is that goes both ways. So essentially that means you could also start with square root of a over square root of b, square root of a over square root of b, and turn that into, if you wanted, square root of a over b, right? The idea is if both numbers are in a square root, you can divide them. So if we scroll down the page a little bit to some of these problems on here, that may come into play a little bit, is that idea of dividing square roots. We also need to remember how to do this thing called rationalizing the denominator. This is where we get the square root out of the bottom, because we're not allowed to have a square root in the bottom. So let's look at example 1, and we'll do a few of these problems together. We have 2 divided by root 3. All right, so it's not a perfect square, so what I need to do is multiply both the top and the bottom by root 3. We did this already, so nothing new here. So the top, 2 root 3. Those are not like, so I can't multiply them together. The bottom is root 3 times root 3, which is just 3. So there's my answer. That is not a negative symbol. That was just a little bit of fraction bar that got separated. All right, problem B. Let's do problem B. 7 over root 5. So this time I'm going to multiply by rad 5 over rad 5 to the top and the bottom. And on top, again, I get 7 rad 5. And on the bottom, I just get 5. So I'll let you guys try C. D is rad 9 over rad 11. Well, there's two things going on here. As soon as you see square root of 9, you should think that's a perfect square. I'm going to simplify that to 3 over rad 11. With all these problems, you want to simplify first if you can. All right, 3 over rad 11. Now I'm going to multiply by rad 11 to the top and the bottom. And I get 3 rad 11 over 11. And that does not simplify, so we're done. Okay. Problem E, I have 12 over square root of 6. Those are not, one's an outside number, one's an inside number, so I cannot simplify that. I have to rationalize. Rad 6 to the top and the bottom. And that gets me 12 rad 6 divided by 6. But in this one, I do have the 12 and the 6 both on the outside, which I can reduce to have it become 2 rad 6. Okay. All right. I want to take a look at a couple more, including a different way of doing some of these. So part G, again, you've got to be have alarms going off when you see a perfect square. Square root of 25 is just 5. Ooh, we zoomed out. Square root of 25 is just 5. So I'm going to not rationalize this. I'm going to go 100 over 5. The square root's gone. Perfect. So my answer is just 20. So always, always, always look for your perfect squares. All right, now problem H and I. I'm going to show you a little trick to make things a little bit nicer. If you start to get bigger numbers, instead of multiplying by itself, so the way we've originally would have done problem H is to multiply by root 12 on the top and the bottom, right? And I get root 12 over 12. But the problem is I'm not done, because square root of 12 can simplify. So I can get square root of 12 is square root of 4 times 3, which is 2 root 3 over 12. But then 2 and 12 can reduce to 1 and 6, so I get rad 3 over 6, right, which took a while. Okay, so I'm going to show you a shortcut for for this problem. Right? Doing it this way is not a problem. You just have to know it takes a little longer. But one thing I could do is if we start over, so down at the bottom of the page, rewrite the problem, 1 over rad 12. The whole goal is to get a perfect square on the bottom, right? We multiply by the number that is already down there, like root 12 times root 12, because that automatically gives us a perfect square. But there are other ways to get perfect squares. So what I'm going to do here is multiply by rad 3 on top and bottom. Any thoughts on why we would multiply to rad 3? Because, look at the top. So the top I'll just get rad 3. But the bottom, rad 12 times rad 3 is rad 36. But square root of 36 is just 6. So I get root 3 over 6, and I'm done. That's it. So a little shortcut is you don't always have to just multiply by the square root itself. You can multiply by any square root that creates a perfect square. Okay. So for I, we've got to be careful because we have a negative symbol in front. I think that's why it's starred. I don't know. But I also am going to say, okay, well, 18, I can get that to be a perfect square pretty quickly by multiplying by rad 2. Because rad 2 times rad 18 would be rad 36. So on the top, I'm going to get the negative still, and then 2 rad 2. On the bottom, I get rad 36, but that's just 6. So I get negative 2 rad 2 over 6. Now we still have to look out for, I got to simplify the 2 over 6 to be 1/3. So it's negative rad 2 over 3. Okay, let's flip the page. Let's do a couple more. So if you look at this whole page here, I think on almost all the problems, the square root's over the whole fraction, or most of the problems. Right? So if we look at problem A here, root 3 over 5, root 3 over 5, I want to simplify it to root 3 on top and root 5 on the bottom, so now I can multiply by rad 5 to create my perfect square on the bottom. I get root 15, those are both inside, so I multiply them together, over root 5 times root 5 is 5. There's my answer. Same idea for B. Multiply by root 7 to the top and the bottom. Where's my pen? Root 7 to the top and the bottom, right? Essentially, because the square root's over the whole thing, we can kind of skip that first step if you wanted. And we get root 14 on top and 7 on the bottom. Let's see. Problem C. Uh-oh, perfect square. Is it jumping out at you? 16. So the bottom is just going to be 4. What's happening? Here we go. The bottom is just going to be 4. So it's going to be root 15 on top over 4. And now I'm good because there's no square root on the bottom anymore. So that's my answer. All right. If we go with problem D now. Another shortcut, another way you can help make these problems easier is if you reduce first. Because these are both square root numbers, I can reduce this fraction, right? Essentially what we're doing is we're going to write it as root 8 over 6, but then root 8 over 6, 8 and 6 both divide by 2, so it's really root 4 over 3. But if you wanted to, you could go right to that from the beginning. I could say 8 and 6 reduced to 4 and 3, so I get root 4 over root 3. The top is 2 over root 3. And now it looks just like some other problems we've done, where I'll multiply by root 3 to the top and the bottom, and I get an answer of 2 root 3 over 3. Okay. That would work on E as well. Root 6 over root 3 reduces, because I can divide, they're both square root numbers, so I can turn that into root 2. 6 divided by 3 is 2. Well, there's no square root in the bottom, so I'm done. Let's do F. Here, 13, the only way to get that to be a perfect square is to multiply by 13. So I'm going to go root 13 to the bottom, root 13 to the top, and I get 2 root 39 on top over 13. Notice I did the square root number times the square root number, and I left the 2 alone outside. Oh, all right. And finally, I think we should look at H and maybe K as well. So h, root 9 over 32. Two things jump out. 9 is a perfect square, and 32 is a pretty big number, so maybe I want to use my multiplication shortcut here. So I'm going to first start with just 3 over root 32. And then instead of multiplying by root 32, because I know I'll have to simplify that later, let's find a number that 32 can be multiplied by to make a perfect square. I know 32 goes into 64 twice, so I'm going to multiply by root 2 to the top and the bottom. And that way I get 3 root 2 on top, and on the bottom I get root 64. And that makes it 3 root 2 over 8 for my final answer. All right, I said we would do k as well, so let's try k. Same idea. I have root 3 over 8. Let's make this root 3 over root 8. Okay, 8 can be made into 16 pretty easily, and 16 is a perfect square. So I'm going to go root 2 to the top and the bottom, and I'm going to get root 6 on top over root 16 on the bottom, which is 4. So it's root 6 over 4. All right, that's all. Thanks for watching.